Welcome to this session of mechanics. Today we are looking at connected particles, and in this specific case we are looking at inclined planes. So our question says the bodies shown are connected by a light strings, meaning the weight of the string has been neglected, which passes over a smooth pulley. There is no friction in the pulley. Calculate the tension T. You can see the tensions here, the normal reaction R, which is here, and the acceleration A. So the acceleration are these two. So this body is 1 kilogram is hanging freely, and then 3 kilograms is on the inclined plane. So when you look at the two bodies, the 3 kilogram mass is heavier than the 1 kilogram mass. So we expect the acceleration of this body to be upward, and the acceleration of the 3 kilogram mass to be down to the plane. So in this case, we know we have three things to be calculated. One is the acceleration, the second one is the tension, and then thirdly the reaction of this body from this plane. So we can start by considering the motion of these connected particles. Since the 1 kilogram mass is moving upward, the tension must overcome the weight of this particle, which is 1g, and the value for g for this case is 9.8 meters per second. So let's continue writing. One of the equations we shall be using is the Newton's second law of motion, which is the force equals to mass times acceleration. So let's get started. For this one, we shall have the tension minus 1g equals the mass, which is 1, times the acceleration a. So when you multiply 1 and g, we get g, 1 and a, we get a. So let's call this one here equation number 1. And let's consider this. Okay, this is for 1 kilogram mass. We also consider for 3 kilogram mass. Now, since it is moving down the plane, the weight must be resolved parallel to the plane, and it must overcome the tension. So we shall have this angle 45 from trigonometry. Now this is 90 degrees if we complete this, meaning the other one is also 45 degrees. The cosine of 45 and sine of 45 is the same. So for this case, we are free either to use cosine when we consider this side, or we use this one here, all the same. So we have 3g cosine of 45 degrees minus the tension must be, that is the force, is resultant force here, must be equal to the mass, which is 3, times acceleration, which is that. And for that case, we can hold this one here equation number 2. So here we have two options, either making T the subject, and then we substitute in equation number 2, or we simply add the two equations together. And preferably, let us add the two equations together prefer bringing equation 1 here. T minus G equals A. That is our equation 1. And then sine tangent of 45 is root 2 over 2. So we shall have here 3G root 2 over 2 minus our tension equals to 3A. So adding the 2, the tension here will cancel because we have positive and negative cancelling off. So I shall have 3G root 2 all over 2 minus G equals A plus 3A. We shall have 4A. Now we have fractional equation here. When we remove the denominator by multiplying through, we shall be having 3G root 2. Of course, this one will disappear from here, and here we shall have 2G equals 4A. Now looking at this, multiplied by 2 also, because these 2 multiplies all these 3 quantities for all equations to be equal. And then when you do that, we shall have our 3G root 2 minus 2G equals to 8A. So it means the value for A will be dividing all the sides by 8. So we shall have, factoring out G, we shall have 3 root 2 minus 2 into G over 8. So our acceleration would be from calculator 3 root 2 minus 2 multiplied by the value of G, which is 9.8, dividing it by 8, we'll be having 2.75, and acceleration is measured in meters per second. Now we are done with our acceleration. So the next is getting the value of T. Simply we take the first equation, which is the most simplest one. So we shall have from equation 1, T will be equal to, taking this G to the other side, we shall have A plus G. So our A has been 2.75 plus 9.8, and then adding the 2 together, 2.75 plus 9.8, we have 12.55, and the tension is Newton. So our tension is being got. And now let's consider resolving perpendicular to this plane in order for us to get some equation that linked the normal reaction. So when you look at this particle, the 3 kilogram mass, resolving it vertically or perpendicular, to the plane. So our R will be equivalent to our 3G. That way is a cos. So cosine of 45 degrees So downward equals upwards, or the sum of the two must be equals to 0. Now from here we know our cosine of 35 is the same as root 2 over 2. So when you press from calculator, 3 times 9.2 root 2 divided by 2 gives us approximately 20.79 newtons. So we are done with these questions. The second question is where we have a body of mass 5 kg is released from rest on the surface of a rough plane in inclined as 30 degrees to the horizontal. If the body takes 2.5 seconds to acquire a speed of 4 meters per second from rest, find the resistance to motion which the body must experience. So in this kind of question, since the incline is a rough surface, then there is frictional force, and this frictional force is the resistance we're trying to gain. So the first thing we need to sketch, we have a picture of this incline. Like if this is our plane, you are free to choose any direction. So we have 30 degrees, and we have the body, assuming the body looks like this, for a particle, a normal reaction is that way, R, and the weight of this body is always acting down perpendicular. From our question, we have 5 kg, which its weight is 5g, and g is 9.8 as usual. And this body is sliding down, so the resistance must be the opposite. Frictional force always opposes motion. If the motion moves upward, the frictional force moves downward. If it moves up downward, the frictional force moves the opposite direction. So let's have our acceleration here, and also to the other perpendicular to the plane, this angle equals to 30 degrees. Now we cannot get this force if we don't know the acceleration. According to this one, the value for acceleration is not given, but we have a statement here that will let us to get this acceleration first before moving into the resolution of these forces. When you look at here, the body was at a rest, meaning the value for u, initial velocity, is 0 meters per second, and then the angle, of course, here has been what? Theta is 30 degrees, and then it attains a velocity of 4 meters per second, and then the acceleration is what we're interested at all looking at. So from the equation of motion, v equals to u plus at. We can make a the subject by subtracting u on both sides and dividing both sides by t. Just make our substitution direct. So we have v, which has been 4, minus u, which has been 0, and our time, we can change it directly to improper fraction by multiplying this, adding 1, making 5 over 2. So when we subtract that is 4, dividing it by 5 over 2, we shall have 4 times 2 over 5, interchanging denominator and numerator. So finally we have 8 over 5 meters per second per second. So this is our acceleration. You can plug in there 8 over 5 meters per second. So now let us go to the question and find what is needful here. Our main question is asking us to find the value for F. For this case is this one, and is the frictional force opposing the motion. So looking at this, we need to resolve the weight here of this particle parallel to the plane in order for us to get an equation that links. So for that case, we have 5g cosine of 60. We have choice, either cosine of 60, because when you add 60 to 30 you get 90, or sine of 30. Both sine 30 and cos 60 makes a half, so they're equal. So I've selected here 60 such that I use cos minus F. If this body should accelerate down this plane, it must overcome the frictional force first. So it means we have to subtract away the frictional force, equals to 5a from Newton's second law of motion. So when you look at this one here, cos 60 is equals to half. So I shall have 5g all over 2 minus f equals 5a. But somewhere we know the value for a. Our value for a was 8 over 5. Meaning the 5 goes off, and we bring this to the other side, so that we have 5g over 2 minus 8 equals to f. So when you simplify this, you realize that the value for f becomes 16.5 Newton. Thank you very much. See you next time.